Let's take a look at a Zener diode. We're going to put together a voltage regulator, and we're going to calculate the resistance we need to limit the current through the diode. Now here's a diagram of a diode, and in the forward voltage it acts just like a regular diode, and when the voltage gets up to say 0.6 volts, it's going to start to conduct current. And you need a series resistor to limit the current through the diode to keep it from burning up. And then in reverse bias, all diodes will eventually break down. They'll have a Zener breakdown or avalanche breakdown, but the Zener diodes are doped in such a way that they break down at a certain voltage. This one happens to be 5.1 volts where this breakdown is going to happen, and this one's a 1N5231B, and it's going to break down at 5.1 volts. Now, whether it's Zener breakdown or avalanche breakdown, it doesn't really matter. They're all a result of ionization of covalent bonds, some with majority carriers and some with minority carriers. But we just care about when it's going to break down at this 5.1 volts. And when that happens over here, we're going to have 5.1 volts on the output here. So we need to calculate this resistor right here to limit the current through this through the Zener. So what we want to do is we'll take a look at the data sheet here, and this is it right here, 5.1 volts. So our Zener test current is going to be 20 milliamps, okay? And what that means is that at 20 milliamps going through there, it's going to put out the 5.1 volts. If we go over the 20 milliamps, then the voltage might change, and if we go below the 20 milliamps, this voltage will change. But at 20 milliamps, we're going to get 5.1 volts out of there, okay? Now, you have to be careful because this is happens to be a half watt Zener. And if we take a look at the chart here for a 1 watt Zener diode, 5.1 volts, same thing, the current is 49 milliamps. And if we try to put 49 milliamps through the half watt one, it's going to get pretty hot. So you want to pick the right data sheet there. So this particular one, it says 20 milliamps. So what we're going to do here is we're going to calculate the resistor. So this R1 here is going to be equal to the input voltage, which is 12 volts DC for me, minus the Zener voltage, which is 5.1, and then we divide that by our Zener test current here. So we've got 6.9 volts divided by our 20 milliamps, so we need a 345 ohm resistor up here. So we're going to put a 345 ohm resistor there, and we should get 5.1 volts out over here. Now, if we put a load on here, say I put a 200 ohm load on here, that means that across the 5 volts, I'm going to have 25 milliamps. So I'm only allowing 20 milliamps to come through here, so I'm going to split the current going through these two things. So this is not going to have 20 milliamps on it anymore. And at 20 milliamps, this would be about 17 ohms here. And now we're going to have 200 ohms over here. So I'm not going to get my 5.1 volts out of there. So what we have to do is, if we know we're going to have a load, a 200 ohm load on here, we're going to have to change this resistor up here, allow more current to flow. So what we do there is we have the same thing. We have the input minus the Zener, and then we have the Zener test current plus the load current, okay? So that's the 20 milliamps plus 25 milliamps, and we divide that into our 6.9 volts. So that means that we need a 153 ohm resistor up here in order to get our 25 milliamps here and our 20 milliamps through this load over here to get our 5.1 volts. So we're going to put it together and see if it works. So here's a unit here, and we'll turn that on. So I've got my 12 volts coming in here, turn that on, and then I can put this to let's see what we got here. There we go. So this is my 5.1 volts, and this is my 20 milliamps coming in here. So that looks good. This is the load current here. So this is the input current, this is the load current, and this is the voltage I have. So now I'm going to add my load here. and see what happens. So I added my load here. Now I've got I'm limiting my current up here to 23 milliamps, and so now I'm down to 4.45 volts. Okay, I've dropped it way down because I'm getting 23 milliamps from my load here, and so now what I'm going to do here is I'm going to add I'm going to change that the Zener Diode resistor and make that 150 ohm one. See if I can do that. There we go. So, not quite right there. Let's see what I got here. There we go. So I've got 40 milliamps coming through there, 27 in there, and 5.1 on the Zener down here. So I have to hold that in place there. But so that's working. So that's how you calculate the put that in the breadboard better there, and I get my 5.1 volts with my load here of 27 milliamps. All right, so that's how you calculate the resistor for Zener Diode. Thank you.